All right, let's talk about something we do dozens, maybe even hundreds of times a day without a second thought. You type a web address into your browser, hit enter, and poof, the website just appears. It feels like magic, doesn't it? But what's really going on behind the scenes is this unbelievably complex, high-speed journey. Today, we're going to trace that entire journey step by step.
Seriously, it all happens in less time than it takes to blink. You want to look something up, you type google.com and bam, there it is. But have you ever actually stopped and wondered what just happened? What invisible, lightning-fast chain reaction did you just set off across the entire globe? Well, that's exactly what we're going to uncover. So our whole mission kicks off with that one simple action. You press the enter key. And that's the starting gun for this whole incredible process. Okay, so the very first thing your browser does is, well, it tries to be smart and save itself some work. It checks its own memory, its cache, to see if you've been to google.com recently. If you have, it's already got the address saved. It's kind of like having your best friend's number on speed dial. You don't have to look it up in your contacts every single time. It's a tiny shortcut that saves precious time. But what if it's your first time visiting? Or maybe it's just been a while and the address isn't in that cache anymore. Well, now your browser has to go find Google's actual digital location out on the vast, sprawling internet. To do that, it needs to consult the internet's master address book. And that giant address book is called the DNS, the Domain Name System. The phone book analogy is perfect here. See, we humans are good with names. Google.com is easy to remember. But computers, they think in numbers. They need a specific numeric address, an IP address, to find anything. The whole job of the DNS is to be that translator, to turn the name we type into the number the computer needs. And finding that number is like a super fast game of telephone. First, your computer asks its local DNS server, probably run by your internet provider. If that server doesn't know, it asks a higher up, a root server. The root server might say, I don't know the full address, but I know who handles all the .com websites. Go talk to them. So the request gets forwarded to the .com server, which then knows exactly where Google's personal address book is. It's this amazing hierarchical search that finds the right number in a flash. And voila! After that lightning-fast hunt, this is what we get back. A string of numbers. This is an IP address, the specific digital coordinate for a Google server on the internet map. The treasure has been found. Now our browser knows exactly where it's going.
Okay, so we have the address, we're ready to just knock on the door, right? Well, not so fast. Before we actually ask for anything, we need to set up a secure, private line of communication. This is where the secret handshake comes in.
That handshake process begins with something called TCP. You can just think of this as your computer dialing the phone number, that IP address we just found. It sends a message saying, "Hey, you there?" The server responds, "Yep, I'm here," and your computer confirms, "Great, I heard you." This little three-way chat makes sure a stable, reliable connection is open before we send anything important. So, the line is open, but is it private? This is the crucial difference between HTTP and HTTPS. An old-school HTTP connection is like sending a postcard. Anyone who intercepts it along the way can read exactly what's on it. But when you see that little S in HTTPS, it stands for secure. That's like putting your postcard inside a locked metal box that only you and the server have the key to. The magic that creates that locked box is called the TLS handshake. In just a few milliseconds, your browser and Google server negotiate. They exchange some secret keys, agree on an encryption method that only they will use for this conversation, and, this part is super important, your browser checks the server's ID. It's called an SSL certificate, and it proves that you're really talking to Google and not some scammer in disguise. Phew. Okay, so the address is found, the connection is stable, and the line is secure and private. The handshakes are done. Now, and only now, can your browser finally ask for the web page. And you know, after all of that complex, high-tech setup, the actual request is surprisingly simple. It's basically just this little text message. It's an HTTP GET request that politely says, "Hey, for the host www.google.com, could you please get me the main page?" It sends along a few other bits of info too, like what browser you're using, so the server knows what it's dealing with. That request zips across the internet and arrives at a massive Google data center. But it doesn't just go to a random computer. It's immediately met by a digital traffic cop called a load balancer. Its entire job is to instantly find a server that's free and ready to handle your request. This is how enormous sites like Google can juggle millions of requests every second without breaking a sweat. The server that gets your request immediately springs into action. It gathers up all the ingredients needed for the web page, the HTML, which is the page's skeleton, the CSS, which is all the styling, the colors, the fonts, and the JavaScript, which provides all the interactivity. It bundles all that, plus the Google logo and any other images, into a package that it breaks down into tiny packets to send back to you. And that brings us to the grand finale. Those tiny packets of data have traveled all the way back across the internet and arrived at your computer. Now it's your browser's turn to shine. It becomes a master builder ready to assemble a beautiful web page from the raw materials it just received. And it builds it in a very specific order. First, it reads the HTML to put up the bare-bones structure. Here's the search bar, here are the buttons. Then it applies the CSS, like a painter, adding all the colors, fonts, and positioning everything just right. And finally, it runs the JavaScript code, which brings the page to life, powering things like those search suggestions that appear as you type. And here is the truly mind-bending part. This entire epic journey we just walked through, the address lookup, the secure handshakes, the request, the response, and your browser building the entire page, all of it happens in a few hundred milliseconds. Less than the blink of an eye. It's an absolutely incredible feat of engineering that we all command billions of times a day. So, the next time you open a browser, take just a half second to appreciate the invisible, high-speed ballet that's happening behind the curtain. It really makes you wonder, doesn't it? What other magic is hiding in plain sight, powering the digital world that we rely on every single day?